We're moving on to 382b. This involves more logarithms, more properties about logarithms. So we're going to start with 21 to 47 odd. And then we're going to move on to the catch the mistake section. You're going to do 67 to 70 all. Okay. So, let's do this. So there are several properties of logarithms that we've already gone over. So 3 squared equals 9 can be turned into log base 3 of 9 equals 2. Okay. If you have log base 6 of 36, you can convert that into a button that your calculator actually has using the change of base formula, ln 36 over the ln of 6. And the same thing works with the log button. Log 36 over log 6. So if you're dealing in a base you don't have, you can convert it to one of the two bases that your calculator has. Or if you have the newer software, you can push math and go to the bottom and get the log base and just type it in as is. Okay? The other one is the power rule. If I have log base 5 of 6 squared, I can move this 2 out front, and I get 2 log base 5 of 6. So if the number you're taking the log of has an exponent, that exponent can move down in front of the logarithm and turn it into a multiplication problem. And that is actually the whole reason we study logarithms, because you can turn an exponential problem into a multiplication problem. So if you have 3 to the x equals 27, you can ln both sides, and then you use the power rule to drop that. X ln 3 equals the ln 27, and then you divide 3. Whereas before, you'd have to guess what that number was, which is kind of a mess. All right, we're going to talk about the other two rules, the product rule and the quotient rule. So if I have log base a of x times y, I can rewrite that as a split logarithm. Log base a of x plus log base a of y. So if you have two logarithms that have the same base added together, you can combine them into a single logarithm where the two numbers you're taking the logarithm of now become multiplication. So that's the product rule. The quotient rule is similar. Log base a of x over y is equal to log base a of x minus log base a of y. And you can go back and forth from either one. Usually, you go from something like this to something like that. So if I had log base 6 of x times a minus 2 over y squared, how would I expand that? How many logarithms am I going to create? 3. This one is going to get a positive logarithm. This one is going to get a positive logarithm. And that one is going to get a negative logarithm. And they're all log base 6. So log base 6 of x plus log base 6 of a minus 2 minus log base 6 of y squared. And if you want, you could say minus 2 log base 6 of y. Who knows what Cynthia Young's going to do? She's untrustworthy. She's not a Boy Scout. She's not a boy or a scout. Okay, what if we went backwards? Well, I'm just going to do base 10. Log of x squared plus log of y minus log of 3x squared plus, well, let's do minus log of 3y. How would you combine that into a single logarithm? Log of, what goes on top? So these two, so x squared and y, and the bottom is going to be 3x squared and 3y, and those cancel, and I'm just left with log of 1/9. Imagine that. Okay, so take a look at 382. So we're going to start, we'll start at 22. Oh, Cynthia Young wants you to pull the exponent down. So 22, we have two positive logarithms, and we're going to drop the -3 and the -5 out front. So -3 log base b of x minus 5 log base b of y. Now wait a minute. I thought that those were going to be positive logs. How come they ended up being negative logs? The exponents are negative, so I could actually rewrite the original problem as this. Log base 6 of 1 over x to the third, y to the fifth. Now this would split into 3 logarithms, right? We would get log base 6 of 1 minus 3 log base 6 of x minus 5 log base 6 of 5, but, or y. Are those the same thing? Does this match that? 22. Well, this piece is the same. What about this? That equals 0. 6 to what power is 1? 0. So that would cancel, and they are in fact equal. Okay, look at number 30. 30 would be log of x minus 3 plus log of x plus 2. Right? Okay. What about 32? So I'm going to change this to 1/2 power, change this to 1/3 power. So 1/2 ln of x plus 3 plus 1/3 ln of x minus 4 minus 4 ln of x plus 1. Okay, does anybody not get that? Okay. What about 34? You guys can handle 33. So 34, we have two quadratics. We need to factor the quadratics first to figure out what the products are. How does the top quadratic factor? X minus 2 and x plus 1. And the bottom one would be x minus 1 and x plus 4. So the simplified or the expanded version would be log of x minus 2 plus log of x minus 3 minus log of x minus 1 minus log of x minus 4. There's no 3. It's a 1. Thank you. Does that make sense? All right. On the next section, you're just going to go backwards. So take a look at 48. The ln of, so the cubed root of x squared plus 4, all divided by the square root of x squared minus 3 times x minus 1. Yeah, this shouldn't be too bad. What's your question? 35. So that's a good question. So this square root is over the entire thing. So it needs to drop down first, 1/2 times everything you do. So you're going to have ln of something plus ln of something minus the ln of something minus the ln of something. But that 1/2 is over the entire fraction, so it needs to come out before you factor it. Yeah, good question. Yes? Yes. So the first one goes on top. So she's asking about 48. Let me go back to that answer. So for 48, this one was a positive, so it's on top. And then this one was negative, so it goes on the bottom, and this one was negative, so it goes on the bottom. That make sense? Jim? So you're talking about this? So the last one's going to be minus 1/2 ln, and x plus 5 has no roots. It has no factors. Well, they're imaginary factors. So it'd be x squared plus 5. That is not factorable. It cannot be turned into a real number product, so it doesn't get split. Just like if it was just x plus 5, that's not factorable either. So yeah, if it's not factorable, then you just treat it as one number. Okay? Any other questions? All right. How exciting. Get to work. Good luck.